Think math.
With 5 values, you put them in order and take the third one. We call that the median, but is it not odd? We picked exactly one value and used none of the others. On what authority does that single value stand for the whole set? Watch what happens the moment you put them in order. Every value acquires a rank. The smallest, the second smallest, and so on. Each value now carries not only its size, but its position. The position is what the median uses. The middle position has a special property. With 5 values, 2 are smaller than the third and 2 are larger. The 2 sides match exactly. So that value splits the data precisely in half. Half below it, half above. That is the credential by which it represents the whole. This approach has a real strength. Change the largest value to 100 or to 1,000,000 and the ranks are unchanged, so the middle position is unchanged too. The median reads which one it is, not how big it is. That is why one owner's salary could not move the median last time. There is a cost, of course. Reading only rank means ignoring entirely how far apart the values are. 2, 3, 4, and 2. 3, 100 have the same median of 3. The mean would treat those two sets as completely different. What each one looks at, and what it refuses to look at, is exactly what separates them. So the median represents by position rather than by size. It is the place with as many below as above, so it halves the data. And reading rank alone keeps it steady against extremes. Next time, why an even number of values makes the middle the average of 2. See you in the next one. A sip of math every day here at Think Math.